Hello everybody, this is Sanjay Das Yogi to give a lecture on design of staircase using limit state method. So as we know, a staircase is the lifeline of a building which gives us the facility to negotiate the elevation. And this is a typical picture of a dog-legged staircase where we will see there are two flights and of equal size. So this dog-legged staircase, we have some specific members and the general arrangement may look like this. And as we know, this is the rise and the component is known as riser, and this is the tread wherein we used to put the footsteps. This is an actual view of the side of a staircase where we will see there are a landing beam, two beams are there. One will be this is the toe beam and this will be the landing beam. Landing is a substance which provides the user to get an intermediate shelter to take rest. So each of the flight should have same numbers of steps. Let us discuss with some example problem. Here we have an example problem where we have got a problem like this: design a dog-legged staircase having a stair hall space 4.5 meter into 2.5 meter where the floor to floor height is 3 meter. Consider user comfort condition and use M20 grade of steel and Fe 500 grade of steel, Fe M20 grade of concrete and Fe 500 grade of steel. This is the combination. So let us discuss the solution. First of all, in step 1 we will discuss on the architectural design of the staircase. So wherein the user comfort condition will be considered. Let us consider the riser R is equal to 150 millimeter and the tread of the staircase T is equals to 250 millimeter, wherein we have floor to floor height equals to 3 meter. Therefore no number of riser required will be 3 meter divided by 150, because 150 is the height of the one riser and you have to negotiate 3 meter. So if I divide it with this riser, the numbers of riser will be 20 numbers. So numbers of riser per flight will be divided equally, because each of the each of the flight should have same size. So it will be 10 numbers, and always you will see number of tread will be 1 less than the number of riser. Why? Because you will see, if I go back to the previous slide, you will see the last riser, after the last riser there will be no tread. It will reach to the landing, and in case of the second flight it will reach to the floor. So there will be a number of tread will be 1 less than the number of risers. So it will be 10 in this present case. So the space required, horizontal space actually required by the tread will be 9 into 0.25, which is 2.25 meter. So if you see here, we have total 4.5 actually. Let us see the problems. It is 4.5 actually. So 2.25, if we subtract from 4.5 it and divide it by 2, it will show that we have space 1.125 in both the sides. And there is a 250 thickness of wall, and if we see there is a space of 2.5 meter width, so it can be divided into 1.2 wide width of the flight and 100 millimeter may be left in the center. So the available space that we have calculated like this. And now what we will do, we will first assume the depth. So let the depth is L by D Let us consider it as 20 because it is a simply supported beam. So just to assume, we are getting it as 2.225 millimeter. So if we want to find out the capital small d, it will be 225 minus 20 nominal cover, and the half diameter reinforcement will be 12 millimeter divided by 2, as we are assuming the diameter of the reinforcement equals to 12 millimeter, and it is giving us 199 millimeter of effective depth for the west slab. Step 3, load calculation. Before we go for the load calculation, if we can see the stair like this, we will see that the spacing is the height is 1.5 and the width is 2.25. If the height by width of the steps or the flight west slab would be divided, we get the tan theta. So tan inverse 1.5 divided by 2.25 will give the pitch angle. This theta, pitch angle, is equals to 33.69. Why we are considering this pitch angle? Because here the staircase is basically a folded plate. Instead of going inside the complicated theory of a folded plate which is placed like this, we are trying to get the projected load of the inclined portion. If we project the load of the hypotenuse to the base, that is, which is a horizontal one, we have to multiply it with the sec theta. So it will become 1.202. So in load calculation, we will see for landing portion, that is the straight portion first, it will be self weight of the slab 0.225 into 25, which is 5.625. Weight of the floor finish is 1.2, as we are considering a stone finish. It will be 1.2 kilonewton per meter square. If it is a normal IPS floor, that is neat cement floor, it will be 1 kilonewton per meter square, and so on. It is detail, it is given in IS 875 part 1, the code of the dead load. So if we consider the live load 3 kilonewton per meter square, the total load is coming as 9.825. Here you have to note, if we are considering the load of the normal floor is 2 kilonewton per meter square, we have to consider live load for the steps as 3 kilonewton per meter square for the staircase, because in the case of emergency, total load will try to move towards the staircase without using the elevator or lift. So if we make it a factored load, it will come as 14.74. Now if we consider the inclined portion, the self weight will be 0.225 into 25 into 1.202, which is coming as 6.76. What is this 1.202? Is the sec theta, that factor. Weight of the floor finish, again 1.2 into sec theta. Number 3 is the weight of the steps. A step, you will see the step is a triangle one, where it will be half base into altitude, that will be half base into base into that trade. That this is the step. If we consider, it is a triangular one. So this is T and this is R. So if we consider unit length of the steps, so it will be half base into altitude, this one, and the density is 25. And if we divide it with T, it will give a nudal. Why? Because if we consider it as 1 meter here, the length, the total load upon this portion, that is this horizontal portion, will be half base into altitude into 25. And if you divide it with the length or the tread of the staircase, you will get the UDL coming on that portion only. And now the live load will be 3 kilonewton per meter square. Mind it, this load should not be multiplied with the sec theta. And this is coming as 13.075, and after multiplying factor, the factored load is coming as 19.61 Newton per millimeter square. So this will be the loading condition, and we have to consider the maximum bending moment, which will occur at the center as the load is symmetric. So maximum bending moment will occur at 2.25 distance from the left hand support. So the reaction, if we calculate the total load and divide it with 2, we'll get the total reaction at the left and the right support. So if we want to consider the maximum bending moment at the center, he will see it will be RA into, this is the reaction, into 2.25, this distance, and then 14.745, that is this load, into the CG distance from here to here. So it will be from the support to here at the center, it is 2.25, and to just subtract 1.125 divided by 2, because the load, the distance will be this CG to the center, so this distance, and we have calculated it like this. And nextly, the 19.625, which is this portion from here up to this, so it will give 1.125, which is this distance. So 19.61 into 1.25 into 1.25 by 2, that is this resulting to 1.125 square divided by 2. So the maximum bending moment is 46.55. So now we, in the step 4, we will check it for the depth, and we know that in Annex G there is a formula where mu lim is equal to 0.36 FCK into XU max by D into 1 minus 0.42 XU max by D into BD square, where B will be considered as 1000 millimeter, as we have considered 1 meter width of the staircase. So here from we will put the maximum moment at mu max, and we'll get the depth required equals to 131.98, and if we add the nominal cover and the half dia reinforcement, it is the required depth is 157.98, which is less than 2.25 millimeter, and it is safe. So the provided depth will be say 200 millimeter. So small d provided will be 174. So we have reduced it from 225 to 200, as the requirement is very less than the provided one. So step 5, we will consider the area of steel. This formula is also available in page 96, Annex G of IS 456, and it will result, if you put the values, it will result to a quadratic equation. And after calculating or solving the quadratic equation, we'll get the value of AST by neglecting the negative value, 683.11. And if we consider 12 millimeter dia of rod, the spacing will come down to 165, and let us provide 150 center to center, which is less than the 3D or 300 millimeter. For the distribution bar, we have to consider minimum reinforcement, and for the slab of Fe 500 grade of steel, it is mentioned in the code IS 456, it will be 0.12% of gross cross sectional area, that is total cross sectional area, B into capital D, and it is coming as 240 millimeter square. And if you want to find out the spacing using 8 torr reinforcement, it is coming as 209.41 millimeter, which is less than 5D or 300 as per the codal provision. So let us provide 8 torr at the rate of 200 center to center. And now the detailing. Here we can see the slab, waste slab, which is thick thickness of the waist slab is starting from the bottom and up to the bottom portion of the steps. This is the thickness of the waist slab. The main reinforcement will be provided at the bottommost layer of the waist slab, which has come as 150 millimeter center to center in case of this problem. And you will see the distribution bar is coming as 8 millimeter 200 center to center. And we have to provide additional reinforcement which is provided up to and development length LD, which is coming as a crossbar in the waist slab, which is also provided in the bottom landing to resist the cracking of the waist slab due to development. If the downward movement of the waist slab occurs, there will be a generation of a crack from this point to upward direction, which may cause a harm effect or ill effect on the waist slab, and that's why this crossbar of reinforcement is provided. And if you want to see how the reinforcement will be provided in the steps, so you can see here which is provided in this staircase detail. So we are referring this one from page number 146 of IS Handbook of IS 456. It is SP 34. So detailing is a very important thing for staircase, and which is shown here with, and we have to show it in the construction drawing, or in the case of students you should show it in the answer script as shown here below. Thank you.